The next family of functions that we're going to talk about is the quadratic function. And you've probably seen these in Algebra 1 a little bit, but the vertex form of this, or I call it the general form, y equals a times x, let me use some different colors, a times x minus h, close the parentheses, squared, plus k. So this should look familiar from the absolute value functions that we talked about, except we obviously had absolute value bars instead of parentheses and this second power up here. But the a, h, and k are still here. Like I told you, we're going to be using these a, h, and k values from now for the rest of the year. And they all do the same thing. So it's really important that you understand what your a value does. So the first thing that the a value does, of course, is tells us that there's a reflection or not. So if a is negative, there is a reflection. It also tells us if there is a vertical shrink or vertical stretch. So we could have a vertical shrink if the absolute value of a is less than 1. So like 1/3, 1/4, 2/5. That gives us a vertical shrink. We get a vertical stretch if the absolute value of a is bigger than 1. So like -5, +11. Those would be vertical stretches. Then the h value, that's your horizontal shift again. And just like with absolute value, it's the opposite of what you would think. So if it says x plus 3 on the inside, that means you're moving left 3. And then the k value is your vertical shift. And just like what it did with absolute value, it's exactly what you see. So -7 means we're going to be shifted down 7. So now let's look at some graphs. So the first step we're going to do when we plot our graph, or when we graph our function, is plot the vertex. And the vertex for this one, you're going to be looking at your vertical and horizontal shifts. So that's +2 on the inside, which means we're shifted left 2. And this +5 is going to be shifted up 5. So the vertex is at -2, 5. So -2 and then up 5. 1, 2, 3, 4, 5. So here is our vertex. The second step is to make a table. And when we make a table, we need 5 points. And the vertex will always go in the middle. And then we go down by 1 on the left side, so -2, then down to -3, then -4, and then up by 1, -1, 0. The reason for this is because these graphs, which are called parabolas, these parabolas are symmetric, which means that the y value when x is -3 and the y value when x is -1 are going to be the same. And the y value when x is -4 is going to be the same as when the x value is 0. So you only are plugging in 2 additional numbers. You don't have to plug in everything else. So let's in our calculator, I'm going to plug in -1. So if I plug in -1 for x, I get +2. So that means that when x is -3, x is also +2 because it's a symmetric. When I plug in 0, I get -7, which means the y value when x is -4 is also -7. So then we're going to plot points. So we already have the vertex plotted, then -3, 2, and -1, 2, and then -4, -7, and then 0, -7. So this looks like that. And something else we have with parabolas is this line right here. This is called the axis of symmetry. Axis of symmetry. And it's going to be the x-coordinate of the vertex. X-coordinate of vertex. This is where you would fold that parabola on top of itself. This is why we can look at just, we only plugged in -1 for x, and then we said, oh, because it's symmetrical, we know the y value when x is -3 as well. So then comparing, remember when I ask you to compare, it's always r, st, r. We do have a reflection over the x-axis. S, there is a vertical stretch by 3. And our translation, we are left 2 and up 5. And the vertex we already wrote down up there as -2, 5. The axis of symmetry is always x equals the x-coordinate of the vertex. So these match. And then the min or max value, that's talking about the biggest y value or the smallest y value we have. If we look at our graph, the vertex is the highest point here. So that means the y value is the highest point. Y equals 5. So these match. Now notice that the axis of symmetry is a line, whereas the min or max is an actual value, and that y value is 5. So we have both parts of the vertex used. The x-coordinate goes with the axis of symmetry, and the y-coordinate goes with the min or max value. Domain, just like with absolute value, the domain of quadratics is -infinity, infinity. Very easy. The range. Since this parabola is open downwards, the smallest y value is -infinity, and the y values go all the way up to 5, which again matches with our vertex. So there's a lot of things that are interconnected with each other in these types of problems. And then the end behavior. We have as x approaches -infinity, which is the left side, and as x approaches +infinity, which means right side, the left side of our graph is going down, and the right side is also going down. So y approaches negative infinity on both sides. And just like with the absolute value graphs, your end behavior will always be going in the same direction. Y will go either to positive infinity on both sides or negative infinity on both sides. All right, let's look at number 2. Now there's no parenthesis in there. We don't have x minus a number or plus a number. So what that really is x minus 0 squared, because we don't need to write minus 0. So our vertex is going to be at 0, comma, negative 6. So we can write that real quick. So I'm going to make my table up here. Okay, so then 1, 2, 3, 4. We want 5 points. The vertex goes in the middle, 0, comma, negative 6. And then our x values will go down by 1. And then we go back to the vertex, and the x values go up by 1. And then I plug in these into the calculator. Well, again, if I'm going to plug in 1, I plug in 1 and I get negative 5.5. That means the y value when I plug in negative 1 is also negative 5.5. When I plug in 2, I get negative 4, which means if I plugged in negative 2, I would get 4. So again, like these should match, and these should match. So let's plot 0, comma, negative 6. Then negative 1, comma, negative 5.5, 1, comma, negative 5.5, 2, comma, negative 4, and negative 2, comma, negative 4. And then your axis of symmetry goes right through the middle. And then we can compare. Let's do the RST. There is none for R because A is not negative. Shrink or stretch, we have a vertical shrink by 1/2. Translation, we are translated just down 6. Axis of symmetry, x equals 0, because remember these should match. Min or max, well, we have a bottom here, so that means it is a minimum value, and it's at y equals negative 6, because then these should match. Domain, negative infinity, comma, infinity. Range, this function is opening upwards, so that minimum value is the smallest y value, and the y values go all the way up to infinity. So then end behavior as x approaches negative infinity, that's the left side, and then as x approaches positive infinity is the right side. Both ends are going up. See, both ends are going up. So y approaches positive infinity, y approaches positive infinity. All right, I'm going to do one more graph for you guys. So we have this one, y equals negative 2 times x minus 5 squared plus 3. The vertex is going to be at positive 5, comma 3. So let's make our table. And put the vertex in the center, 5, comma 3. Okay, now my x values, I'm going to go down by 1. So 4, 3. And then for the vertex again, the x values are going to go up by 1, 6, 7. So then I'm going to plug in either 3 and 4 into the calculator or 6 and 7 into the calculator and then do my symmetry. When I plug in 4, I got 1. And when I plugged in 3, I got -5. So that means the y value should be over here as well. Again, these should match, and these should match. So then the RST, we do have a -2 in front, so that means there is a reflection. So reflection over x-axis. Shrink or stretch, we have a vertical stretch by 2. And then translation, we are translated right 5 and up 2. Sorry, up 3. So now let's graph these points. We have 5, 3, 6, 1, 4, 1, 3, -5, 7, -5. So then my graph looks like this. And then my axis of symmetry again goes right through the middle. So my axis of symmetry is going to be x equals 5. Now for the min or max, since we have a top of this function, it is a max, and that's y equals 3. Domain, again, -infinity, infinity. Range, the smallest y value is -infinity, and we go up to 3 because this function is going down. So it's going to, the y values are going to go all the way down to -infinity. And then the left side and the right side end behaviors, both sides are going down. So y approaches -infinity on both sides. So again, there is a lot here, but this is why when we were doing the earlier stuff like end behavior, domain and range, and RST, that I just focused on those things specifically so that you could get good at them. So when we put it all together, you're going to be able to do this just fine. So this example here will put these functions in real-world context. So it says you hit a golf ball and make a hole in one. The trajectory, this means path. The path of the ball is given by that function, where x is the horizontal distance and y is the height of the ball. And then we're going to answer these questions about it. What is the maximum height of the ball? Well, up here, we had maximum values at the vertex right here. So let's figure out the vertex of this. The vertex is 88, 16. You can see we have -88 and we have +16. And this negative sign out in front just tells us that this function is open. This function opens downwards. So we have a maximum value. So the maximum height is this y value right here, 16 yards. And then B, how far is the ball from you at its highest point? Well, that is going to be the x value here. It is 88 yards. So there wasn't really any math involved. This was more about interpreting the problem and knowing that the vertex is the maximum or minimum value of our quadratic functions. So for examples 4 and, well, the second example 4, I want you guys to try these on your own. Pause the video. Look back up here at the graphs that I did for you if you need to, and then try to answer these questions. This example 4 isn't asking you to graph, it's just asking you to compare your RST, and it's asking you then to identify domain, range, and end behavior. I gave you this graph here in case you wanted to sketch it out to help you out, but you don't need to. But this one down here, I do want you to graph. So pause the video, try these out, and then once you're done, unpause it so you can check your answers. All right, here's the answer for example number 4. Notice that it's a vertical stretch by 7/2 because 7/2 is bigger than 1. 7 divided by 2 is 3.5, and that's bigger than 1. So make sure you don't fall for that trap. So those are the answers for that one. And then here is the graph that you had to do. Oh, whoops, I didn't put in the y values here. So I hope that this was not too difficult for you because you did such a great job with absolute value functions. So if you need to rewatch a little bit of this and clear up any misunderstandings you have. So thanks for watching, and make sure you like the video and subscribe.